in this video. Hello everybody and welcome to the 44th video on the channel. I'm so happy you're here watching, and before we go on to our answers to our previous questions or even the proof of this video, please make sure to like, subscribe, and hit that notification for more awesome content just like this. And please make sure to comment down below any suggestions or video ideas, and please make sure to have some feedback on the channel so I can always improve my videos for you guys. Thank you so much. Let's move on to our answers to our previous question. Alright, for our last video, we only had one practice problem, and the answer to that practice problem was 6. Let's move on to the geometry proof. Alright, today's proof is the angle bisector theorem. That is, if a line AD bisects the angle BAC, that means AB divided by AC is equal to BD divided by BC. Now, what we're going to do is we're going to prove that theorem today. And so, for just the knowledge, and proofs are always good because they teach you why something is as it is instead of just what it is, which I think is a major part of learning anything. Alright, let's go with the proof. The first step of the proof is to draw a line that's parallel to AB. So, and that starts on point C. So if we draw a line, and then we call that line CE, we extend AD. So we draw a line AD, and the point where the extension of AD and the extension of C, when they meet, that is point. We'll call that point E. So we have a triangle CED. So that's our triangle. Now let's prove that triangles ABD and triangles CED are similar triangles. So we have to prove that the angles of those triangles are equal. Now DEC is equal to BAD. Those angles are equal because if you look at it, the CE and AB are parallel, so it's kind of like parallel lines, and then you have a transversal or something that's intersecting it. So it's kind of like alternate interior angles. So that's why those two angles are equal to each other. Now the second angle is, since angle BDA and angle EDC are vertical angles, they're also equal to each other. Alright, since two angles are equal, the third angle is also equal. So now we have proved that triangles ABD triangle, we have triangles CDE, those two triangles are similar. Alright, now that we have those two triangles proven as similar, let's move on to the next step, which is creating a relationship. So, a mathematical relationship, not a real life one. So, what we have to do is we have to look at the ratios of the sides. Now, what we can do is we can do each corresponding side. So, what we have here is we have AB is equal to CAB divided by, now the side that corresponds to AB is CE. So, AB divided by CE is equal to BD divided by DC, since those two sides are the corresponding sides. So AB divided by CE is equal to BD divided by DC. Now let's just quickly move that away and write that again. Alright, now that we have that, we are so close. It's just that instead of AC, we have CE. So, what are we going to do? It's pretty simple. First, let me redraw this figure because it looks very goofy and it's not even close to what actually is going on. So if I quickly redraw this figure, alright, we've redrawn that really quickly. So what we need to do is if we prove CE is equal to AC, we have our theorem. So how do we do that? The answer to that is in fact quite simple. Now if you look at it, angles DAC and CED are both equal to each other. So that means the corresponding sides, AC and CE, are equal to each other. Or if you don't want to go that route and think that's kind of like a shortcut, well, it is a shortcut. If you look at it, if two angles are equal, that's an isosceles triangle. And since CE and AC are the corresponding sides, CE is equal to AC because of isosceles triangle rules. So, in the very end, after all that work, we get AB divided by AC is equal to BD divided by BC. And that's our theorem. And that's our proof, sorry. Thank you so much for watching this video. See you in the next one. Hope you enjoyed, and bye-bye.